Good evening, my dear students. So today in these sessions we are going to learn regarding the internal combustion engine. So the internal combustion engine, in which combustions take place within the engine. In the internal combustion engine, in which combustions can take place within the engine, the chemical energy of fuels is converted to the thermal energy, and this thermal energy is converted into the mechanical energy. The chemical energy of the fuel is converted into thermal energy. This thermal energy is converted into the mechanical energy in the internal combustion engine. The classification of internal combustion engine. The internal combustion engine is broadly classified into two types. The first one is 4-stroke engine and second one is 2-stroke engine. These 4-stroke engines nowadays we are using in the Splendor, any vehicle those are exist nowadays, as well as this 2-stroke engine. So already we are used, so these 2-stroke engines we are using in Luna nowadays, is it right? As well as this 4-stroke engine as well as 2-stroke engine is broadly classified into two types. The first one is SI engine. SI engine nothing but spark ignition engine. So this SI engine is suitable for petrol engine as well as it's suitable for gas engine, is it right? As well as CI engine, the compression ignition engine, it is suitable for diesel engine. CI engine is broadly classified into two types. The first one is dual fuels, or we can say as multi fuels, as well as divided chamber. Okay, as well as according to Sankey diagram, they having the losses of 80%. The heat from fuels, is it right? The first one is the heat losses of 80% because of surrounding temperature losses is 12%, exhaust losses is 33%, coolant losses is 35%. That much is losses is occurring due to the combustion of the engine. So we are observed with the help of Sankey diagram. So this internal combustion engine losses are calculated by using the heat balance sheet. This internal combustion engine's losses are calculated by using the heat balance sheet. So this heat balance sheet, the performance of engine is usually studied by the heat balance sheet. The performance of engine is usually we are studied by the heat balance sheet. The main component of the heat balance sheet are, the first one is how much amount of heat supplied by the fuels, how much amount of fuels supplied, and second one is heat equivalent of effective work of the engine, and third one is heat rejected to the cooling medium, and fourth one is heat carried away by the exhaust gases, and unaccounted losses in the internal combustion engine. The first one we are going to learn regarding the heat supplied by the fuel. The heat supplied by the fuels is equal to how much amount of heat supplied is equal to the fuel supplied per unit time into calorific value of how much calorific value of fuel used in per kilojoule per kg. And second one is heat equivalent of BP. So BP is equal to the equivalent of BP we can measure by 2 pi nt by 60,000 kilowatt. And third one is heat taken away by the cooling water. So heat taken away by the cooling water is equal to the mass of cooling water used in kg per second, and T1 is indicate that inlet temperature of cooling water, T2 is represent outlet temperature of cooling water, and CPW is represent the specific heat of water. So the heat taken away by the cooling water is equal to the mass of cooling water is used in kg per second into specific heat of water as well as in bracket outlet temperature of cooling water minus inlet temperature of the cooling water we are measured in kg kilojoule per second. And fourth one is heat carried away by the exhaust gases. So heat carried away by the exhaust gases should be equal to the how much amount of mass flow rate of the exhaust gases into specific heat of exhaust gases in bracket temperature of exhaust gases minus room temperature. From that we can easily find out the value of how much amount of heat carried away by the exhaust gases. And unaccounted losses we can measure by A minus B plus C and D. With the help of we can easily find out the unaccounted losses we can measure. So in the next topic we are going to learn regarding the electrical energy. I hope so you understood very well. No one is having the doubt regarding this section. If you have the small doubt regarding this section, please write down in the comment box, and please don't forget to subscribe my channel. Thank you.